This video is for class 9 physics, and today we are dealing with the topic importance of the law of gravitation. So you can imagine, for the people before the concept of gravity, it was so confusing for them to understand, to observe things falling on the earth, the motion of planets around the sun and the motion of moon around the earth. So it was very hard for them to understand this, why the objects are falling on the surface of the earth. So now we all know it's because of gravity. So Newton was able to explain all these kinds of motion because of the law of gravitation which he framed. That's the importance of law of gravitation. Coming to the next topic, which is force due to gravity. According to the law of gravitation, you all know this, any two objects which has mass kept in the space will attract each other. The earth similarly attracts any object around it towards its center. So why towards its center? Because we can take the mass of the earth at its center, mass of any object at its center. The force with which the earth attracts a body is called the force due to gravity on the body, which can be taken to act vertically downwards. So since force is a vector quantity, so its direction will be vertically downwards for the force due to gravity at the center of gravity of the body. So where? At the center of gravity of the body. You will understand center of gravity in class 10 in detail. So in vertical motion near the earth, in vertical motion near the earth surface for a height much smaller than the radius of the earth, the force of gravity on the body is assumed to be same throughout. Let me try to explain this. What we have learned is, suppose there is one object, right? And suppose I can consider this as the surface of the earth. The earth will attract the object and the object falls down, right? So the force has a direction downwards, vertically downwards. Which force? The force due to gravity. Now what we have understood from the previous videos, that is, when I consider any two objects, this like this, and suppose they are separated by a distance r. Remember, this distance is taken from their center, right? Then we took force of gravity as capital G, mass of the first body, mass of the second body upon distance square. That's what we studied, right? So whenever an object is falling on the surface of the earth, right? This is earth, right? Object is falling on the surface of the earth, we need to take the distance from the center of the object to the center of the earth, right? So that's why the word a center of gravity was used out there. Now trying to explain the second part, which is in vertical motion near the earth's surface for a height much smaller than the radius of the earth, the force of gravity on the body is assumed to be same throughout. Suppose, again let us try to understand this. This is the surface of the earth, and you are jumping from a staircase, right? So when you are jumping on the surface of the earth from a staircase, then since you have your different parts of the body like head, hands, leg, right? So all these parts will experience same amount of force because all these parts belongs to you, right? That's what it means. It means that whenever the object is falling on the surface of the earth, right? If the object is very small compared to the earth, then what happens is the gravity acting on each part of the body is same, or I can say the gravity acting on the whole object is same, either it be your head or leg. I hope you understood this.